This is the second of two conceptual examples for integration by parts. So this one looks confusing, but let's break it down. We're integrating g of x times cosine of x over 2 dx, and it gives us the result, and it just doesn't tell us what g of x is. So with this information, what could g of x be? So the way to handle this one is to just go normally. You're going to let u be g of x and dv be cosine of x over 2 dx. So you know cosine's the dv because you know you integrated the cosine because we have this factor of 2 out here. If cosine was the u and we had to differentiate, then it would be a factor of 1/2 out there somewhere. So that's the hint that tells you that for this question, u was g of x and v is the rest. dv is the rest. dv equals cosine of x over 2 dx. So the derivative of u is g prime of x. So we're doing dx. Everything normally. So v is the integral of cosine, which is positive sine times 2. And now we just use our formula. This integral then is u times v. So u v 2 sine of x over 2 minus the integral of v du. Now, so du is this. So since we have a 2 sine x squared out here, and you know by this, after we put the g prime in, we're going to get a 8x cubed. That means the g prime must have been 4x cubed dx. That would make this the same. So now we know what g prime of x is. The question is, what could g of x, what could it be? What could be an expression for g of x? So we're going to have to integrate this. And so notice it doesn't say what could be the expression, it's an expression, because the integral is indefinite, it'll give you a plus c, but one antiderivative would be x to the 4th. So there you go. Right here. So the answer to this question is A.